Welcome to solverfy.
So we previously found that the surface integral of f times the gradient of g dot n hat ds is equal, by the divergence theorem, to the triple volume integral of f times the Laplacian of g plus the gradient of g dotted into the gradient of f. So now we're going to use that to prove that f dot g minus g gradient f, and then this whole quantity dotted into n hat ds is equal to the triple volume integral of f Laplacian of g minus g Laplacian of f. Now with this initial equation from previous questions at the top here, this is pretty easy. So if we know our rules about vector calculus, we know that we can split up these operations using the properties of vector addition. So we have the surface of our first gradient, and then if we dot that into n hat ds, and then plus our other part, which is the surface integral of negative g gradient f dot n hat ds. Now, we know by our divergence theorem that this is equal it's actually over the volume of our divergence of f, which, if we look back up at the top here, can be simplified down to this term. So we have f Laplacian of g plus the gradient of f dotted into the gradient of g dv. And now we can use that same property for our second integral and just flip the g and the f. So we have a minus sign and n, so we factor that out. We get the triple integral of the same volume of g Laplacian of f plus the gradient of f dotted into the gradient of g dv. Now, because these have the same bounds, they can be added back together. So we have this entire equation is equal to the volume integral, in parentheses, f gradient squared of g, I'll put that in another parenthesis, plus the gradient of f dotted into the gradient of g, minus our next one, which is g Laplacian of f, plus the gradient of f dotted into the gradient of g. Now that is all multiplied by our differential volume dv. Because I can't fit that, I'll write it right below. So now we can combine these two. So we have, notice that we have one positive gradient of f dotted into gradient of g. And then if we distribute this negative sign into here, we have one negative gradient of f times gradient of g. So those two actually cancel with each other, and we're left with the volume integral of f Laplacian of g minus g Laplacian of f, or the equation that we were trying to prove.